Hello students, welcome back to my channel. In today's video, we will learn graphs of piecewise-defined functions. A piecewise-defined function is usually defined by more than one formula that is a formula for each interval. In simple words, a piecewise-defined function means a combination of different kinds of functions on a single graph. We used to learn different kinds of functions such as linear function, quadratic function, cubic function, and so on. And we used to sketch a single graph for a single function. For example, if we are given a linear function, then we sketch a linear graph. If we are given a cubic function, then we sketch a cubic graph. But for piecewise-defined functions, we might be given quadratic function, linear function, and cubic function all together. And we need to sketch a single graph for these three types of functions. So a piecewise-defined function is a combination of different types of function. Okay, so let's look at example 1.7. Sketch the graph of each of the following piecewise-defined functions. State the range of each function. So we're given three functions. f of x equals to 1 over 3 x squared minus 3. This is a quadratic function because the biggest power of x is 2. So this is a quadratic function. Second function, f of x equals to x minus 3. This is a linear function because the biggest power of x is 1. And the third function, f of x equals to x minus 3 power 3. This is a cubic function because the biggest power of x is 3. So this is a cubic function. To sketch a quadratic graph, we used to learn that we have two types of quadratic graph. The first type is like this. And the second type is like this. The pattern of a quadratic graph depends on A. If A is positive, the graph is like this. If A is negative, the graph is like this. We are given 1 over 3 x squared minus 3. 1 over 3 is positive, so the A is positive. So we choose a positive graph. Next, we find the x-intercept of this function. To find the x-intercept, let y equals to 0. So 0 equals to 1 over 3 x squared minus 3. So 1 over 3 x squared equals to 3. X squared equals to 9. X equals to plus minus square root 9. So x could be positive 3 or negative 3. So the x-intercepts of this quadratic function are 3 and negative 3. But we have a restriction here. X must be smaller than 0. It means that x must be negative. So the x should be negative 3 only. Negative 3 will be the only x-intercept of this quadratic function. Let's find the y-intercept now. To find y-intercept, let x equals to 0. So y will be 1 over 3 times 0 squared minus 3. Any number times 0 will be 0. So y equals to negative 3. So our y-intercept is negative 3. So the x-intercept is negative 3. The y-intercept is negative 3. And we have done sketching the part for the function y equals to 1 over 3 x squared minus 3. Since x is smaller than 0, so we cannot sketch a complete quadratic graph because x must be negative only. Let's look at the linear function x minus 3. Let's find the x-intercept. To find the x-intercept, let y equals to 0. So 0 equals to x minus 3. X equals to 3. so the x-intercept is 3. Let's find the y-intercept now. To find y-intercept, x equals to 0. So y equals to 0 minus 3. Y equals to negative 3. So the y-intercept is negative 3. Then we label the y-intercept as negative 3. Then we label the x-intercept as 3. And then we draw a line passes through the y and x intercepts to form a linear graph for the function y equals to x minus 3. Lastly, we look at the cubic function. We need to sketch a cubic graph for this cubic function. Based on what we learned in the previous videos, there are two types of cubic graphs. First type is like this, and the second type is like this. One is going up, one is going down. If the graph is going up from left to right, then this is a positive cubic graph. If the graph is going down from left to right, then this is a negative cubic graph. By looking at the given cubic function, we know that the x cubed term is positive. So we choose this graph. Let's find the x-intercept. To find x-intercept, let y equals to 0. 0 equals to x minus 3 power 3. X minus 3 equals to cube root 0. So x minus 3 equals to 0. X equals to 3, so the x-intercept is 3. Let's find the y-intercept. Let x equals to 0. Y equals to 0 minus 3 power 3. Equals to negative 3 power 3 equals to negative 27. So the y-intercept is negative 27. So the cubic graph will look like this. But we don't need the lower part. We only need the upper part because the lower part is occupied by a linear graph we sketched just now. So we just need the upper part like this. The range of f is greater than negative 3. From the graph, we see that the range is greater than negative 3. Notice that there is no break in the graph of the function because the graph is continuous one after another. We say that the graph is continuous on the interval negative infinity to positive infinity. Because you can continue sketching the graph to the left. To the left means to the negative infinity. You can also continue sketching the graph to the right. To the right means to the positive infinity. So the graph is continuous on the interval negative infinity to positive infinity.